But now, by the way, we don't have episode numbers anymore, Eric.
Oh, that's good.
Yeah, we're going for some modern message
title?
digest type system, which is basically made of names and titles, and then we'll include the title, but the number's going to be like a message digest.
Oh,
We want a cryptographically secure episode.
We should base it on my sunset time, right?
is it a digest of the MP3 data, or is it a digest of the title?
Ooh.
You know something? That's not a bad idea. At the moment, we've kind of went with names of the people that are involved. But maybe we can include the digest of the data of the MP3. Yeah,
that way people could check it.
Cool.
Is this the authentic Defen podcast, or has it been adulterated in some way?
Oh man!
Make sure they don't cut out the good parts. Yeah,
that is a great idea. We should keep this in.
Fake.
Okay?
Oh, totally.
Deep fake some words.
Yeah, this is the beginning of this episode number FO327.
It's great that you can guess the digest before we've even recorded it. That's awesome. That's great.
There's going to be an FO somewhere in there.
F off, maybe.
Oh, F off. Oh, man. That's going to be
that should be the beginning. Yeah, of everyone. Beginning, middle, or end. It's like.
Oh, Jesus.
What's the class file? The Java class
Cafe
file format,
Babe, isn't it?
Cafe Babe.
Oh, yeah.
That's
Cafe
right.
Babe. Yeah. We
gotta figure out. We gotta write a program that writes out every possible, letters of hex, and then checks it against a dictionary to see if it means something.
Well, I've got Babashka and I've got a dict file, so give me 2 minutes.
And closure. I mean, you just do it so fast.
By the way, this is not the sort of podcast you can get your dict file out on. Just leave it in the computer. We are recording now. Okay, welcome to the show.
Welcome to the show.
No, do not cut that. That is dad joke-tastic. That is.
So this is the part where you say "Welcome to Defen," episode F off Cafe Babe something, right?
Right. Okay. Well, welcome to the podcast, and Eric, welcome to you back
Thank
again.
You. Yes,
I think you're our most repeated, most frequent visitor.
Yeah, and I'm trying to keep it that way.
Yeah,
you asked me to come on. I have to say yes, otherwise someone's going to catch up.
Exactly.
True.
Well, Josh has told me he's got to go through all the guests again and interview them properly. Me and VJ made an absolute mess of it last time. So, people want to rewrite closure whenever they see someone else's closure.
That's right.
Oh,
it's just like he's got the same vibe about Defen. That's why he's here. Do it all properly, right, Josh? What we're going to do this time, man?
The big rewrite.
Yeah.
Well, I'm going to rewrite closure in LLVM. Oh, wait. No, that's been done. Never mind.
In Rust. That's the big... No, that's been
being done too, right?
Oh,
by some
man.
some jerk. I don't know. WebAssembly. Somebody's doing that.
Yeah.
Closure and closure is all... It used to be a hot topic.
Nice. It's closure all the way down.
Yeah.
But...
wasn't it one of those things which would have been possible, for ClojureScript in ClojureScript because of the way that the protocols were done, because of protocols and stuff?
Yeah,
but it's too late for Clojure, I think.
Yeah, certainly the way Rich likes to keep backwards bug compatibility and everything.
Yeah,
because he likes his commits. I committed it; it's in there. It's not broken. Don't fix it. So, it's what keeps it stable.
Yeah.
I
was going to say.
Right. All that dead space can go away. Now let's move into something more fun.
More fun.
Eric, you came here on the back of a wonderful conference we all visited and joined and enjoyed.
Sure.
The Heart of Closure in Leuven in Belgium, where Josh came on a few bike rides with me.
I
Nice.
did.
and
Nearly died. Yep.
A few like 2-hour, 15-minute bike rides. Yeah.
Something
That's what I hear. A little detour on their 15-minute bike ride.
well, yeah, I did say half an hour at the beginning, and it turned out to be about an hour. But okay, I think half an hour to an hour. That's within reasonable. I think
sure, on a bike. Yeah.
The estimate is okay.
Yeah.
I blame those guys for being a bit slow. That's all.
Well,
sure. Yeah.
Evo was slow, man. Slow, ripping his jeans, all sorts of excuses.
Intense.
Well, anyway, yeah, it was a really great conference. I mean, we were very lucky.
Lovely.
The weather was fantastic, and everything was great about the whole scene, really.
Yeah.
But you gave the keynote, Eric, the closing keynote.
Right. That's right.
So, I mean, obviously we'll talk about some of the things that you were mentioning there, but what was your kind of like lasting impression of the conference and of Belgium? Maybe, I don't know. I think it's your first time visiting, or
I had been to Bruges 20-something years ago.
Right.
Just like
it's a fairy tale
backpacking
town
through Europe. Oh yeah, Bruges is amazing in terms of just the you don't see medieval architecture like that anymore. You might see a building here or there that survived, but this is like basically most of the town is still intact. But Leuven was amazing. I just had no idea. It's such a lovely place. It's old, so it has like a 550-year-old like city hall building that is adorned with hundreds of statues. I mean, it's just, it's the kind of thing that as an American, I walk by and I'm like, how can you not stop and just gawk at this thing every time? But of course, in Europe, you're like, you're used to it. And
I'm not sure, actually. I think that is a particularly impressive one. I mean, I gawked at it when I came over here, and I still gawk at it when I go past it. So,
and the statues are still there. They haven't been like knocked over. I guess they're pretty high, most of them. But a lot of the stuff. I used to live in Paris.
Weed's legal in Belgium. They are pretty high.
A lot of the statues in Paris have been defamed or defaced either by the revolutionaries or something happened to them over the 500 years. And so it was just cool to see, like, this thing is like not mint, like new, let's say. And they keep them clean too. They wash them. I mean, they must have washed them in the last decade, which is, not something they would do in Paris either. So I don't know. And then I also, because of the weather, just having all of these outdoor seating, like outdoor restaurants, was like so amazing. Like it literally looked like the whole city could go to lunch at the same time, and there would be a table outside for everybody.
And make sure it's a nice long one as well.
Exactly. Well, there's enough for everybody. So like 2 hours, if your restaurant is full, just go to the next one. And I just always get very envious because in the US, you usually have to drive to a place, and the outdoor seating is not great, and the service isn't good. And this is like amazing that there's within walking distance hundreds of restaurants, all with 30 to 40 tables outside. So lovely. And then the location of the conference was on the square in front of the train station. Which also was really big and spacious, and it also had cafes all around. And so it's the thing I mentioned in my newsletter about the conference. That was great that you didn't have to be inside cramped in the kind of dark theater that we were in. But you did lose something, which is the serendipity. It was a little too open. Like someone could, you wouldn't notice that this person sitting, 2 cafes down is another closurist, because they're mixed in with all the other people, and it's a little too far away to to like interact and like say, hey, can I join your conversation? You know?
Yeah.
So I feel like it was great that it was like Arna said, hey, use the space outside. But then you kind of do lose that, like you're all in the same space. You can identify each other easily. You're kind of bumping into each other.
There was a little bit outside HAL 5 that was like that, if you remember.
No, HAL 5 was nice for that.
I even sat with you talking about some book or other. I can't
some
remember
books,
what it was now.
yeah. No, HAL 5 was nice for that. There, because so just for the people who weren't there was lunch served at HAL 5 for the whole conference.
Great lunch too.
Yeah, it was really a great lunch. It was like a buffet, and then there were all these picnic tables outside, and reserved for us, I think, for the conference goers. And you just grab a plate, fill it up, go sit outside, and it was amazing. There's like you're just surrounded by 50 to 100 closurists all eating and chatting and you know, mingling, and just kind of random chance who you sit next to, and that's all great. And it does go to the like kind of purpose of the conference, which you know, I ran a conference, right? And one of the things that I was trying to not do was to have talks, right? Because when I go to conferences, I like to do the hallway track. And everyone I talk to, even not just the hallway trackers, other people who go to conferences, they say, yeah, my favorite part is the hallway track. It's always the best. So I'm like, well, why don't we just cut out the talks? If everyone just wants to hang out, you know? There's some logistical issues with that, because the talks do serve a couple purposes. They, you know, when you're convincing your manager, give me a week off so I can go travel, like maybe you'll pay for it, and they say, well, why should I do that? What's in it for the company? And then you can point to the talks like, well, they're using Kafka and there's a talk about closure in Kafka, and like, you know, I'll learn something and get to talk to this person. And then they're like, okay, whatever, you can go. But if you don't have a talk and all you can say is like, well, I don't know who's going to be there, but it'll be fun. It's not quite the same argument, right? And then also for people, like, there is a draw where you see Rich Hickey on the, you know, giving a talk, David Nolan's giving a talk. And yeah, maybe you want to see it live. There's kind of that, you know, why do you go to listen to a band live when you have their CD? You know, the audio is going to be way better on your stereo than in the, but also they're going to be mingling. They're going to be there. You might meet David Nolan. You might meet Rich Hickey. So there's something to that too. And it's not just like, I'm going to meet Rich Hickey. It's I'm going to meet other people who also want to meet Rich Hickey. And so we'll have something in common. And
because I think being in the audience watching a talk live, there is something to that, right? Like I do enjoy, you know, sitting next to, whether it's Ray, you know, arguing about whether a given talk is good or not. Or, you know, if it's somebody that I haven't met yet and we're laughing at, you know, some inside closure joke or whatever, like there is that sort of sense of camaraderie. And like, I feel you on the hallway track. I have a slightly different perspective. For me, it's like, I need the talks to make the hallway track fun, because I like hear an idea or something, and then I'm like energized. I'm excited to talk about it. So it kind of feeds into it. So
yeah. I can see that too. I also have I have that experience, but I also have the other experience, which is, you know, 6 talks in, and like my mind shuts down. I'm not hearing anything anymore. And even sometimes, like before I was aware of that going on, I'd be like, that wasn't a very good talk. It didn't excite me. And then I'll see it pop up on YouTube 6 months later, and I'll watch it and I'll be like, this is awesome. Why didn't I see that? And then I realized I like kind of ignored it because I had been there. And I think to me, the experience of watching videos in general, sometimes it is great to be there, but in general, I have a better experience of talks when I get to choose when I watch them. You know, like I'm ready for this one. I'm interested. The title sounds good. It's not just because it's next, you know, and during the conference. So, you know, that's just me though. But anyway, what I'm trying to talk about is Heart of Closure and how great it was. It was awesome to be in Europe. It was my first European closure conference. Just to meet all the people who like rarely get over to the US. That was awesome. There's so much activity in Europe around closure, and that's cool. And it's, you know, just like Europe is, you know, relatively dense, small and compact, and like everything's close. Like you're getting people from all over these different countries that could travel there by train, usually, sometimes by plane, and it was a bicycle, even. Someone was on like a houseboat down a canal. Like you got everything. And that's also cool that you got this big diversity of people, and you know, it's like it's a lot of people but in a smaller area, so you're just getting a lot more activity. Whereas in the US, you got centers that are like thousands of miles apart, and it changes the dynamic of it. So it was just great to be in Europe, you know. Let's see what else. The talks.
Sorry, go ahead. Yeah, I was just going to say the talks were good. Talks.
Yeah. No, you should watch the talks. They're good. I think what Josh wanted to talk about around the talks is I wrote this newsletter article, like it's called A Love Letter to Heart of Closure. It really was the best conference I've been to. But I was expecting something a little different. So there was some part of it that like didn't meet my expectations, and that was the subjects of the talks. So not the talks themselves, you know, each talk was good, but when a lot of the rhetoric around the Heart of Closure is like, it's like very human centered, and it's about the people, and it did feel like that in terms of like the logistics of the conference. You know, Arna was talking about, you know, being inclusive, like open up your discussion circles so that there's room for someone to kind of just come in, go have lunch together, do an activity after the conference. If you need to have space, go to a cafe outside. Like he talked about that, but I thought that would also flow into the topic selection of the talks, right? And so I compared it to a conference I went to locally here in the town where I live. And that conference, it was a Ruby conference. And the talks were much more people-centric. So, you know, there was this, the theme of the talk was, we're all people. The programmers are people, the business people you work with are people, sales, all that. The support people, your customers are people. So basically the idea is programming is about people. So let's get better at learning about people and being good people and stuff like that. And so a lot of the talks were like, let's talk about personality traits, and let's talk about emotions. And, you know, it was a much different theme than what I saw, which was more like just technical stuff. Like I'm writing what is Jank? It's is it LLVM?
Yeah, that's
a closure in C++.
Closure in C++. That's right. it's just like, okay, that's another technical talk. It's just how to write this compiler. Oh, I had this sailing problem and I wanted to solve it in Clojure. Very, very much like you would see in Clojure conferences. Still cool, still Clojure-y, but just didn't hit my expectation.
I mean, interestingly, I get that vibe because I get what you're saying, because obviously we work with like software and like Clojure potentially every day. And a lot of there are some things around Clojure that are like, they're always like sparking joy, let's say, when you discover something, or you see how neatly you can express something. That's a little, ooh, that's quite nice. But a lot of projects actually are about, dealing with the bloody, the messy people. We want to make, I want to make this change. I think that's going to take a bit too long. No, it won't. Honestly, it's going to be fine. No, but I think you should do something else. It's like, I don't give a fuck what you think, really. Oh God, I've got to. You're my boss.
Right.
So it's all these kind of
how
things.
How do we deal with that? Yeah.
How do we deal with it? And it's
internal
very
conflict
tricky.
And
Well,
yeah.
Okay.
There's all. Sorry, go on, Josh. Yeah.
But yeah, I was going to say, like, there was actually a talk talking exactly about this, right? It was the talk that Philippa and Martin did on the replacing the legacy software system at that logistics company. They were talking exactly about how they had this amazing like technical solution that was replacing this old AS400 system, and like they weren't getting any traction. And then they discovered, what did they call it? They found the graybeards and these different groups of people. And so it was a people problem that they couldn't solve. So they kind of pivoted to a different group of people and got some traction there. So that talk was exactly about what you're talking about, I think.
Yeah.
I mean, it was one of the talks about something to do with people, but I think Eric's right in the sense that it wasn't a dominant theme. I think you're right as well to pick that one talk that was about like the fact that they were negotiating with different parts of the company, and in the end, they all became good friends. It was a kind of like a
oh, it's a heartwarming story.
It was a heartwarming story. It was beautiful. I mean,
in
the end,
That's
it's an ongoing story, which is fun as well.
Their talk reminded me how like the real value of a contractor is that they're an outsider.
Yes.
And they can bridge all these connections between different factions inside the company and like skip over red tape, just like get something done, make some. I had an experience as a contractor like that once. I was actually an employee for a company, but we were hired to do an integration with their system, and it was exactly like that. It was like these old processes, very waterfall. Nobody had any agency, and like through maybe a little bit of their fault because they weren't practicing agency, but also like maybe there's a good reason they weren't practicing. And so, man, I remember having to fly out to them. This is after months of working with them, like weekly meetings on the phone. Like, how's it going? How's your side of the integration going? Oh, it's just fine. Everything works. And then you get there and they've never run it. They've never, they've never run the software that they've written. Like, hello, like we've had months, like you start it, see what happens. Like, does it talk to our system or not? And they're like, oh, but there's a firewall and I can't poke a hole in. Like, walk over to, it's like it's one floor, like go over there. That's where the operations people are. Talk to them about poking a hole in the firewall. And he would walk over there and he's like, oh, they said no. Like, okay, let me go with you. And I held his hand.
Computer says no.
And we walked over there and we explained better like what we needed to do and how the deadline was in 3 days. And please, can we have a thing? And we agreed on this, and it was just like, I had to be the one to like be the ambassador and talk to all the different groups and get things done. And that's how big companies work. And that's why nothing happens.
Cool.
Yeah. I think that I'll just say one thing on that before we pivot a little bit. But I think that's great about starting a new job. And I know, Ray, you've just recently started. You have that first 6 months to be an outsider. And you can actually bridge a lot of gaps in that first 6 months because, everybody has nothing against you, when you come in and start.
You haven't made enemies yet.
You haven't made enemies, yeah. So,
well, you're making enemies. That's what you're doing,
right? Yes. Choose your enemies now.
Actively making enemies. Yeah. So, one of the other talks was about obstacles on the path to closure adoption, and that was an interesting one. And I know you have some. I don't know how you want to say it. You have your ear to the ground or your nose to the radiator or something. Anyway, you have a magical way to spot trends in closure adoption, Eric, I think. So how's it going? Is closure being adopted?
That's the really, I don't know where to start. So I'll just start somewhere. So my magical signal is not too great. It's that my course sales are something of a signal about what's happening in the closure community because I sell to beginners, and so it's a good way to know how many new people are interested in closure. Also, I look at my like website stats, what are people visiting? That is kind of a signal too. And the traffic has been going down over time. Like, and who knows if that's like SEO or whatever, but it's a signal that I have. And, you look at Google Trends and all that stuff. And compared to other languages, closure is not keeping up. Like it just proportionally even. Like, if everybody had 10% growth a year or something like that, you'd see that everybody's growing and there's going to be exponentials because it's compounding. But closure like goes up and then it kind of is trailing off, right? And I think that most people who are not in the closure community would think that closure is not that exciting right now, that there's not much happening. And I can see that. Like, I don't think we have what used to look like some silver bullets, some like killer apps. When closure first came out, first of all, it was a totally different environment. Like this is, when you're talking 2007, there weren't a lot of great options for a non-mainstream language, right? Like we're talking like Ruby was like, oh wow, it's came out of nowhere, right? And that was one of the big sort of, I don't know, what do you call it, non-mainstream. You had your Java, your C#, your Python, even JavaScript wasn't big back then. And so it was like a new thing with like an advantage. It ran on the JVM. You got this big ecosystem. And then it also had good concurrency. And at that time, we were all excited about getting thousands of cores on our machines, right? That was what people were talking about. Like we had 2, then 4, then 8, and like, when are we gonna, how many doublings before we're at 1 million? So we were excited that we had a story for that with all the concurrency stuff. That didn't pan out. And I don't know if there's anything now that's there. Even ClojureScript had a good story, which was that it was better than JavaScript when it came out. Came out in like 2011 or something. And, JavaScript has improved quite a bit. And it also has a big ecosystem of libraries and stuff. And we don't have a thing that makes Clojure that much better. That, I don't know. Here's the cynical part. That doesn't take, 5 years to learn, right? Mm-hmm. I think that's another thing.
Yeah.
Like especially someone like me who's been using Clojure for so long, I forget that like it's not the stuff that I know that makes me fast. I didn't learn it overnight. It wasn't like, oh, I just did import XYZ and I could do all this stuff, right? And a lot of people aren't there, especially as the industry grows. It's growing from the bottom, right? It's growing from people who have no experience.
Yeah.
And we don't have a story for them, right? And I don't think it's about installation. I don't think it's about tooling. I think that it's a cycle, right? So it's like it's a bootstrapping problem. It's like how do you get people to learn this stuff? And you need some motivation. They need a reason. And a job is a good reason, but we don't have that many jobs. And why don't we have that many jobs? Well, there's not enough people to do them. Or the people you need have to be so senior that you can't afford them. There's stuff like that. And it's just this cycle that we don't have a good answer for it. So there you go.
Man, let's just end the show. I'm bummed out. Jesus. All right.
Yeah.
What are we moving on to?
You wanted to do it right, Josh. Do the interviews over again. I mean, you've just killed the show. I mean,
it's well, yeah, I mean, listen. I'm gonna. So I know I just opened this in a very downer note.
Yeah, we're heading to the mountain at the moment. The fuel lights are flashing. The altimeter's going down.
Yeah.
Let's get out of this nosedive, guys. Come on.
Yeah. So I do want to say that the energy in the Clojure community, the people who are here, there's a lot going on. Like there's a lot happening. It's just not. I think a lot of it is not like the kind of, I don't know, the kind of hype that you get in other languages.
Yeah.
So, the whole scientific Clojure work that's going on, like that has a lot of pieces that need to be put together.
Yeah.
Right. It's like, and a lot of that putting together, I don't think is that hard. It's like documentation and tutorials and things like that. If they could just pull it together and show some practical, like this is how you get an AI stack in Clojure, so that you can start doing some LLM training, or I don't know what it would be, but they're close to that. It's just at the moment, like to use as an example, the Python Clojure thing, the bridge that lets you run all the Python libraries for machine learning. In Clojure, there's no good tutorials, and I've tried it. I've booted it up. I've brought up a Python tutorial, AI tutorial, and I'm like, I'm just gonna translate this code into Clojure, and I couldn't do it. There were just too many things that I couldn't find, and I'm honestly maybe not the right person to do it because I'm not good at chatting. Like I'm not a chatter, never been one. And a lot of these communities are like docs are ask the chat, ask the Discord. Right. And I'm not good at that. I want to document. I want to be able to search it. I don't want to talk to somebody.
You're not alone.
Yeah. So, I feel like that. So like, I guess part of why I'm bringing that up is like, I wish I could help, but I can't. Like, I'm not there. I mean, maybe I just need to suck it up and like talk to somebody. But I mean,
reach out to Eric. If you're listening to this, reach out to Eric.
Yeah.
But they're so close, is what I mean. They've got all these pieces. They've got talks every week about what's happening in the community. They're building so much cool stuff. It's not unless you're involved in the community very heavily, you can't be a part of it because it's not easy to use. So anyway,
so they're writing the PhD thesis now. They haven't published it yet. That's the point, I guess.
Yeah, and they'll talk to you all day on chat about how to, solve a problem using it, like what libraries you need to use. There's like Babashka and that stuff. The small closure interpreter, the SCI, the stuff that is going on there, like scripting in Clojure has never been better, never. And that was a complaint people used to have, but they don't have that anymore. Like, the slow startup times, I can't write it for little scripts. Like, oh, you got Babashka. And just all the stuff that enables, it's all there. It's just like maybe too late, So I look at something like Elixir, right?
Yeah.
Elixir is maybe smaller than Clojure, but it was really fast adoption. It grew super fast.
Yeah.
And I think that there's still excitement in the community because Jose, the guy who created Elixir, talks at every single conference.
Yeah.
He talks at the American one. He talks at the European one. Like, he's just always talking about something. And the talk is not great. It's not like just it's not like one of these Rich Hickey talks that's going to like stand the test of time. It's just like the things that he's working on, and it just, he has an energy. And he's like, we're working on this type system for Elixir. And there's, we've been tracking the growth and here's what it looks like. And it's just like a status update, similar to what Alex Miller does.
Yeah.
But with more energy and more frequently. And it's just not something that we have. There's another thing that the Clojure community is not as great at. This is the whole community, not just Cognitect. A Ruby programmer who like moves to a new town and looks around is like, wait, there's no regional Ruby conference here. I guess I'll start it. That's so common, right? And there's like a lot of Laravel podcasts, like you'll like 10 Laravel podcasts. It's a framework that'll, it's very popular, but a lot of people haven't heard of it, but there's 10 podcasts. And how many Clojure podcasts are there? Maybe 2. And we've been around for a long time. And, this one isn't even weekly.
Damn, sick burn, dude.
Well,
wow, okay, yeah.
It's just a fact. Just a fact.
We are not corporate sponsored, by the way. I just want to say that.
Yeah, well, and that's part of it. There's no sponsors for these things, so like,
yeah, that's right. Yeah.
There's no hope that like, if I put in my time, I'll get paid for it. No, it's not there. So like, we just don't have that that same community minded, like, I'm gonna get us together kind of vibe that you see in other communities.
I think we have it. I think we have it more in Europe, Eric, actually, because this is the thing I really missed with the pandemic, because we used to have 87 Clojure conferences a year here, right, Ray? I mean, a ridiculous number for such a small area. Yeah. And with the pandemic that went away, but they're starting to come back. And it's funny you mentioned Elixir and Ruby, because I did Elixir for a while and I absolutely loved it. I loved the community. I loved the programming experience. I mean, it is the only non-Lisp I've had like an amazing interactive development experience, like sitting in Emacs, doing all the repling. It's like amazing. And but the other thing it has going for it is, Jose Valim comes from the Ruby community, and he brought his people with him. And Rubyists are like amazing. They're super friendly. They're excited. They want to tell you all about it. One thing that I think Rubyists are almost unique in is they're not shitting on anyone. Like they just want to tell you all about how cool everything is. And they're like, oh, you're coming from PHP? Cool. I used to do that. Like, here's what Ruby can do, blah, blah, blah. And I think like there is a bit of that energy, I think, in the European Clojure community as well, where people are just excited and they want to tell you about stuff. And yeah, there are a few people like me who always have to make node jokes or whatever. But, luckily I'm the minority in the community. So
we do have to watch out for that. There are a lot of in-jokes that are like anti-JavaScript, and it's not, it's like maybe not even a joke. It's just like a passing comment. Where it's like, or at least it's not JavaScript. Someone will say that. And it's like, oh, come on. Like there's half the audience here has to do JavaScript.
Yeah.
And they're not
totally.
Maybe they're not unhappy about JavaScript and you just alienated them. Like,
all right. So we were talking about Elixir, I think, and JavaScript and basically not shitting on other communities. And I was just saying to Josh, I might have been guilty of that myself on this very podcast at some point. But I will, I will definitely.
We all have.
I will sort of own it, but I'm not proud of it. That's for sure. And I feel like there's, if we look back on things, I mean, things like JavaScript and PHP, the dynamic nature of those languages is something which we should be relishing. We should be joyous about, like Ruby as well, because we're a dynamic language, And by the way, one of the things I find quite annoying about Clojure in the industrial setting is that people want to have it as an executable, or they want to compile it, or this kind. No, I mean, maybe it will squeeze out that bit of performance that you really need. But I would much rather be having a kind of environment, a production environment, which was much more interpreted, because it's good enough. In the end, this interpreting thing, gets boiled down to JVM bytecode, and it will go fast. Will go fast pretty quick. It will be fine.
The JIT will kick in. The JVM will work its magic. I mean, Clojure is
but
not.
My point, Eric, though, is that my quick point is that distribution becomes a zero. It's not a problem anymore.
Yeah,
you just copy your source code, boom, you're done. Like PHP,
it's true.
That's what we used to like. We used to like, we just have an FTP thing open.
Yeah,
we just drop the PHP and bam, we're done. The change
the next page load runs that code.
You say Skittle, but it's actually Clojure. That's my point. Is that we're kind of like we don't have to invent a whole new thing.
Yeah, no, it's true. So like I have this side project that I recently put together, and I was wondering how can I have the fastest deploy. I don't want a whole pipeline. I don't want a Jenkins that looks at the GitHub pull requests and I don't want all that. I just want something. I hit a keystroke on my machine. I'm a single developer. It's my own project. I just hit a keystroke and it happens within seconds, right? And what I landed on, I don't know if this is the best possible, but what I landed on was if it's a simple code change, I push to GitHub and then I SSH into my machine. It does a git pull, so I get the new code, and then I REPL in, so I have a REPL open behind a firewall, so I have to be SSH into the machine, and then I just I just do a require core reload all, and it just reloads all the code with the new code, so it doesn't even restart the JVM. And for a lot of simple changes, that's good enough. And I also have another keystroke that's, actually restart the server, right? It is the last advantage that Clojure has. I'm just going to put it that way.
Yeah.
Interactive programming.
Yeah, absolutely.
The fact that you are you're working on I mean, Stu Halloway puts it the right way, that it's you're working on a partially correct program. It's running and it's partially correct. It's not done yet, but it's already running.
Yeah.
And that's something that is really hard to do with types, right? To have it running when the types aren't right yet. And it's something that you can do with the REPL because you're like modifying the code. You're redefining functions on the fly. The thing is, like I was hinting at before, that's like a multi-year process to get good at that, to get good working with that. And what you were saying, Josh, was Elixir had something like that. And I listened to Erlang talks. Elixir runs on the Erlang VM.
Yeah.
They're doing stuff that I think is awesome. But I'm also like, is that written down somewhere? Because like, I don't want to spend 5 years figuring it out for myself. I would like someone to just tell me this is the best practice, and maybe explain like why we don't do it this other way, this other path. No, we tried it, doesn't work. But like, just bootstrap that information in me, because I think Erlang has similar problem to Clojure. Like we just
100%.
don't talk about it enough. And try to explain it. But like Erlang people are doing some cool stuff with their VM. And like the fact that, here's just an example. I was watching a talk. They built a system during COVID for a hospital that had, since they started, 100% uptime. And they had it like triple redundancy, where like there were 3 servers running in different data centers, and they were all syncing between each other. And then, but there was no database. There was no separate database server. Right? Because it was just all, because of the redundancy, if one went down, they could start it back up and it would sync again and get a backup from the other 2. And it's like, wow, I would love to work with just Clojure data structures in memory and not have to map to like a SQL statement for everything that I think is important enough to save till later, and like come up with a table schema, and just like, oh, I'm just working with Clojure in memory and it's saving it all and it's never going to go away. Like, I'd love that. But, they have that. But the thing is, it just also sounded like they had 15, 20 years of experience with it. And so they knew exactly how to boot it up so that that worked. And I don't think it's written down.
Can I suggest something to you? I mean, I'm actually working on a system right now with Kafka and Clojure, and there's a nice symbiotic thing there, because with Kafka you can persist anything, and with Clojure you can write anything, and they have essentially like a key value store underlying Kafka, and which is very and you can use Eden data structures on there as well. So it's really close to like a perfectly distributed system. But like you say, Clojure wasn't built as like Erlang, like the beam is something magical that Ericsson wanted as a always up, always on system. And so they built everything around that concept. And we don't have that. We're sitting on the JVM, and it's really about essentially the convenience and the sort of dynamicity of Lisp, not really about kind of like the infrastructure, So there's definitely a different vibe.
It's definitely different
between the two things.
But I can also understand that, like, I invented this reload all thing. Like, I don't think I read it anywhere. Would someone with a couple years of Clojure experience be able to come up with it? I don't know. Or like know when to run one versus when you're going to have to reload the whole JVM. I don't know.
I think this whole component system was built around this kind of concept, though, wasn't it?
Yeah.
So I think, and again, like, I don't want to say, it was Stuart
Sierra.
Stuart Sierra, and I know that they've now transitioned, but I think they accept their old name for certain libraries and things. So, I don't want to dead name them, but they themselves in a blog post said that they would accept that name for their work in the past. So anyway, so kudos to them for being open about their whole situation, but also, but they actually made that jump themselves. But the problem to me with the component system is that it's very infectious, and it tends to then be
protocols
like,
everywhere.
I'm now the dominant. I now own your code base, basically.
Yeah.
Which is, I think it's a kind of natural thing that if you have you want a certain guarantee or a certain set of infrastructure things, then
you need to buy into like certain,
that. Yeah. You're buying into certain like concepts or certain protocols or processes or ways of doing things. Let's say. Anyway, right.
But wait, let's stay on that point, because I think that's actually a problem, because we have like a lot of the stuff written about Clojure, or like the quote unquote right way to do Clojure, is with stuff like that, right? So it's with component or whatever the new thing is, and I see people who are like relative beginners to Clojure. They've been doing it a year or two, and they have like protocols, they have def records, they have all this stuff all over the place, and it's like, but all you need are data structures, and you have all of this ceremony, and you're struggling with Clojure, and you're like, well, this isn't really any better than Java. It's like, yeah, not if you write it that way. And so there's this weird disconnect between people who really know what they're doing for building these big systems where you actually do want protocols and def records and so on, where they actually do help you. But that is not the case for the vast majority of Clojure programmers and the vast majority of programs they're writing. So this is the weird, like, and this is, I think, going back to your how do we get people started with Clojure thing, Eric, that's a great question. I don't have an answer.
So what you're bringing up, like, I think it hits at a really key issue. There's okay, so there was this blog post, I don't know, 10, 11, 12 years ago, when Clojure was getting really hot, by Steve Yagi. He was still kind of active blogging.
Legend.
He was a Lisper, he had done Lisp, and very a legend. Introduced a lot of people to Emacs, which was cool. But he was he wrote I think he was on the Clojure mailing list when it was still like a Google group, or a Data News or whatever. Yeah. And what he said was that Clojure was a no culture. No, N-O. Negative culture, meaning someone would say, oh, how do I do this in Clojure? And the first answer would be, no, you shouldn't be doing that. Shouldn't do it that way. There's always a no. Like, oh, here's the right way to do it. And I think that he was right. Like, after being in the Clojure community so long, I even do it. It's like you see someone write protocols when they're not really needed, and you're like, oh, don't do the protocol. But the thing is, it's working. Their code is good and working, and and they're just using the tools that the language gave them. And maybe we should be a little bit more, a little bit more like, okay, bite our tongue a little bit and say
just and you though.
we'll start, but like my whole thing is to start with the praise, start with the congratulations.
Sure.
You got a program working in a new programming language, new to you.
Yeah.
Like, good job. Now, let's go over how we can improve it. Instead, it's a lot of negative, like, oh, don't put a def inside of a function, don't do this. And it's like, whoa, that's a lot of critique for a beginner.
But do you think that's actually happening in the Clojure community? Because I don't see a lot of that. So like what I'm talking about is I'm not talking about like criticizing people for having protocols when they don't need them.
Yeah.
What I'm getting at is like, why are people writing this code?
No,
because,
I agree too.
You know,
I agree with that.
They're not
the
having
other
fun.
side of it. Right. That's the other side of it where they're, as beginners, they're maybe they see a parallel between their Java object orientation and protocols. And they're like, oh, this is how you do it in Clojure. And so they're kind of writing Java in Clojure. And I agree with that too. That's going to happen. I'm gonna yes and you that that it does happen. And the thing is, it happens. It happens in every community. Someone is writing their last language in their new language.
Yeah. 100%.
And we have to support that like transition in a positive way. And I think that it's similar to like how people will often say something like you know, don't use a macro. Like you don't, like, probably like your default should be don't use a macro until you really know you need it. But that same person probably spent a year playing with macros to learn that.
Definitely.
Yeah.
And so they're not supporting someone else playing for a year with them. And they're trying to, I don't know, maybe save someone from a year of wasted time or what, but they come off as negative. They come off as, instead they're doing like, do as I say, not as I do.
Right.
And what we need is more like, oh wow, protocols, that's a cool way to use them. Let me show you how to do it without protocols. You know, like your implementation of protocols is 50 lines of code. If you just used a Clojure map, it would be 3 lines of code. And a couple keywords. So
I think the other thing, by the way, with macros, which I mean, I think we've kind of been like dog whipped into not liking macros, and I sort of rejected that a few years ago and decided that I will write a macro a year or something like this. And I mean, the question is why, and I think that's the problem, is that like we often miss like, why should we write a macro? Why shouldn't we write a macro? Perfectly good reasons to write a macro.
Yeah.
There's perfectly good reasons not to write a macro.
Yeah.
And half of the bloody this whole Coda async is written in a macro.
Yeah.
Didn't have to be, but it was. So some of the bosses are using it. That's for sure. Deps is written in a lot of macros. Spec, sorry. But and again, you could argue that it shouldn't be written in macros, but it is. But for me, I often think about it as a way of like, I think like all of us do, it's a way of reducing boilerplate, and it's one of the powers of language. If you see repetition and you can't get away from, you could use function passing, but what about if you just like used a macro instead, and it wouldn't it be so much easier? And yes, especially for things like exception handling, it makes a lot of sense. But there are certain things where you want to like put things together, and you can't compose macros, and then hey presto, you're out. You're out of luck.
Right. Sure.
But people don't. And I think as long as you can be clear that look, and again, education is what it's all about, Eric. That's where you're coming from. That's your jam, and it's very difficult to. Like you say, it's a people problem. People want to come in and they've got an ego. They were very good at their previous language, and they want to be good at this language because they're a good programmer.
Right. And there's no guide that's like, hey, if you've been doing object-oriented programming in Java, and you've got all these ideas about how a program should be structured, it's not subtle like, oh, you translate your for loop into a map filter reduce chain or something. It's not that simple. It's like you first start with this idea of like, I'm gonna have this class and it's gonna talk to this class and talk to this class. And so you start like, well, I'm gonna need something that's that class. Like, is it a protocol? Is it a namespace? Like, where does it, like, no, you don't need all that, but that's where they're coming from. But we don't have a guide for that person. We don't like it. And I say we're negative. We have the no culture. Like, it's just one way of saying that like, there's no, we don't as people in the closure community answering the questions and trying to guide people, we don't have those resources. So like I see a lot like, okay, one of the reasons why I think spec did not succeed was it had a very no culture. So when someone would ask, well, how do I do a closed map? The answer was always, you shouldn't do a closed map. And, we've found that every time we do a closed map, we regret it. And so we're just not going to even have that feature.
Right.
And it's like, okay, but like this isn't the only thing you're saying no to. It's like every single question is an answer like that. What are we supposed to do with this thing? If you have all these great best practices, like, oh, we do it this way because of this, and we do it that way because, you're not sharing them. Like, they're not saying, like, I mean, I remember when spec was released. Here we go, like, maybe be canceled again. But when spec was released, it was on, I think, the Cognicast podcast, where Rich Hickey was interviewed about it, and he was like, yeah, we made these great tools, and we're looking forward to seeing what people do with them. And then the no's started coming back from them, like, oh no, not like that, that's not what we meant, meant. Like, well, you're the one who just opened the door and just said, let's see what you do with it. Like, give us some guidance. Because I do think that they might have a lot of great wisdom about how to build these systems using it. But I don't see that, more positive guidance coming. That's,
damn.
And so I think that happens about everything. Like, how do we work with maps? I don't even know. Like, someone who's like steeped in a very type-based language, they're like, how do you, you're just throwing stuff in a map? And I'm like, yes. And it works. But then there's probably like a million little practices that I have that my coworkers have about how to make it work so it doesn't turn into garbage really fast.
A great example of that, Eric, was this the Spectre library, where
Nathan Mars, I think.
Nathan Mars, the Red Planet guy, very smart guy, and he came out with this very big closure advocate as well, and he came out with this library called Spectre.
Closure's missing.
Right, he called it Closure's missing core library.
Yeah, exactly.
I mean, he's got an ego. Fair enough.
That's right. That's right.
He's done some great stuff. So okay, he's got an ego. But and
shout out, Rama.
yeah, exactly. Again, big claims. Anyway, but the point is that he came out with this like Spectre library, and I mean, basically everyone was saying no. It's like, well, you shouldn't make your maps like that. Your maps shouldn't be that deep or that complicated to require such a complicated library as Spectre. And it was kind of like a very peculiar thing, because there was Nathan like making claims that like, well, in the real world, there are these like complicated maps and these complicated data structures. And here's a library which will actually help you. Yeah, it's a bit complicated, and I've done some documentation on it. Maybe it's not enough. Who knows? I've never used it, to be honest, in anger.
Where in the real world we have that complicated stuff? And the 8 gigabyte JSON files that APIs are returning to us, right?
Yeah, sure.
yeah, probably. Yeah,
for sure.
Yeah. But my point is that like you were saying, like if you have a preference about how to use maps, then you wouldn't need the Spectre library, and you would need like, oh, right, if you want to do a reduce and you've got updating, you've got ASOC, you've got ASOC in, you've got all these sort of things. This is the sort of thing that you should be doing. This is your real world data structure, and this is how you manipulate it using the core libraries. And if you want to go outside of it, then you might need to invent something that does this or does that or does the other. And we're not going to do that because it doesn't have like generic appeal. But that kind of thing could be interesting. Again, from a developer relationship perspective, if they have people like that who want to, sponsor content or whatever, it could be, this could be all great stuff,
Mm-hmm.
or like, the sort of stuff that you're making in your courses,
Well, and like Jonathan Sharvit's book, The Data-Oriented Programming, I felt like that was a really great attempt at explaining like what is this data-oriented thing we're doing anyway. It to me, like it was great that it happened, but the sad thing is like, wow, we hadn't really tried to tell anybody yet. Like, and I mean, even like beginners, like we didn't know what to say. We're just like, use a map. What are you doing? And he actually broke it down into, I think it turned into 4 principles by the end of the book.
Right.
That was like, at first you're like, no, it's more complicated. No, it can't be that. Like, no. And then like after a while of thinking about it, I'm like, oh yeah, that's kind of it. That's what it is. It's just using generic data structures. What's another one? Functional programming. So like immutable. So there's 4 principles. I can't remember them all. I think it's don't do validation at runtime instead of at compile time, stuff like that.
Right, closure is the
sensible
first
stuff.
Well, yeah, and he has a whole tree that he worked. As I'm an author, and I know like you think so deeply about these ideas, like you want to schematize it, but then it's like this isn't really appropriate for the book. He has a whole cool tree that's like, you take the left branch, you're using immutable. You take the right branch, you're using mutable, and like you kind of walk down these choices. And you arrive at data-oriented programming on one branch, and functional programming is like is another choice, right? So it's cool that he's actually gone deep on it and thought about it.
Yeah. Well, speaking of going deep and thinking, the reason we ostensibly had you on was to talk about abstraction, and shit has gotten pretty abstract already. So, but just to kind of wrap off this, like, you've given me something to think about that I haven't thought about before, which is like, we need a book, closure for Java devs that is not here's how to write for with MapReduce and filter instead, but is actually like, here is how to build a real program, because if you're coming from Java, you're probably building industrial software, right? Or sorry, that sort of program. And I think another interesting way into it, though, is like the way that a lot of people have come to closure is they've seen a Rich Hickey talk and they've seen the ideas and then they checked it out. And like that's actually something I think you're pretty good at, which is talking about ideas. And in your newsletter, quite a lot of the time, you don't even mention closure, right? You're talking about ideas, but then every once in a while you do mention closure. And I think I wrote a blog post about the Heart of Closure conference, which I still haven't published. So I'm even later than your month late wrap up. But in your closing keynote, I don't know if you said the word closure in your talk. So
I don't think I did, actually.
Yeah. So what in the world were you doing on stage at a closure conference not talking about closure?
Yeah, good question. So my original idea for the talk, and I think it kind of stuck pretty close to that, was to, again, also I was expecting the talks to be much more about people, like I talked about before. It was about how abstraction is this uniquely human thing, this human skill that we have, and just kind of explore that and celebrate our skill of abstraction.
Mm-hmm.
So I mean, that was kind of the like beginning idea of that talk, and I think I got pretty close to that. It explored abstraction from, you know, the fossil record of like how can we figure out the cognitive capabilities of like pre human hominids. And there's actually, it's not just me, I didn't do any real research into that, but there's a whole branch called cognitive archaeology that's looking into this, and I just looked at what they said basically. But put it in a talk form, and then went through some examples of in history of like important moments in the history of ideas that were like now kind of we all take for granted as like this is how abstraction works, and it's like no, that was invented by like one person, and we all do it now. And so just like trying to set up this idea that we've got this legacy that we're all carrying around, of, you know, genetic legacy, and then a cultural, like educational legacy that we can make use of in our lives.
So the thing, I think this is absolutely right, but one of the things that I posit is that I mean, we are all abstracting all the time, but I posit, I think you posit it, maybe is in your talk as well, that every level of abstraction kind of in the human world, people drop off. So as we get into further and further, like depths or heights of abstraction, let's say, you know, people get dropped off. So a great example to me is like the difference between arithmetic, algebra, and calculus. Right. Now, those three things.
Not everybody makes it to calculus. Yeah.
Yeah. Not everyone makes it to algebra.
Right.
Yeah.
Right. No, it's true.
So I feel like there's that kind of although it's correct, I feel like there's some abstractions, and I don't want to be elitist about these things, because I'm not saying that, you know, there are certain people that can abstract and certain people that can't. That's bullshit. But you know, it depends on
it depends on education. Like you just need to have that experience, really, unless you're Newton or, I mean, you know what I'm saying. Like you have to be very special to come up with it on your own.
Yeah, exactly. And so this is kind of like
let's jump on that, because
okay.
you said the word invented by one person, and then you have to be pretty special to come up with it on your own. But the calculus was invented more or less by Newton and Leibniz at the same time, right? So something was in the air.
That's right. I think they're putting pieces together.
Yeah, it's a scientific community, you know.
Sure.
So this was, in a way, a hive mind, of which Isaac Newton, you know, like, I'm not saying he was just some dude. Like, clearly, you know, he made some leap that, you know, only one other person was currently making at the same time. So I don't mean to shit on Newton. I mean, I could. You know, there's all sorts of reasons to do that.
It's true.
Wow.
We don't need to go there.
I think it's too soon. It's too soon.
Too soon.
Your man drank mercury. I mean, come on.
Well, yeah, no.
If that's what it takes, Josh. If that's what it takes,
you're absolutely right, and that's kind of one of the themes that I tried to weave through. I don't know if it came through. It probably didn't, but that the ideas are often co-invented, independently co-invented. Not two people working together, but two people working sometimes apart, or like one person will invent it and then like their journal is like lost for 100 years, and then someone else will invent it in the meantime, and then it turns out that they invented the same thing. But yes, there's something like in the air. They're all working in a group, communicating. There's also the privilege that a lot of people have in this. So like Newton being like independently wealthy, able to just be a scholar and not, work in a coal mine or whatever. And
until they made him run the mint, right?
And could afford, well, yeah, right. But he could afford all of the like equipment, right? He could afford to like order these weird chemicals from all over the world that were very rare at the time,
and drank them.
Yeah, and like, well, he drank them, he burned them, he did all the alchemy stuff.
He was
actually
he was an alchemist.
And also, this is the thing I wanted to get into in the talk, which I didn't, which is I think we shit on alchemy too much. Like,
totally.
Like, when was the last time you invented chemistry? That's what I want to say whenever somebody's like, oh, those alchemists, they thought they could turn lead into gold. Ha ha. Dude, they were doing real stuff that chemists still do. They're melting compounds and doing reactions. They just didn't know what was going on, and they were doing their best to explain it.
It's in the name. Come on.
Yes, exactly.
By the way, the other thing I was going to say to you was, and I think you mentioned it in the talk, and it's not mentioned enough, is that, and this is sort of so like annoying to me and frustrating, is that some people at least, have this concept that like Western civilization is responsible for all of like the benefits that we have in the modern world, and it's so bullshit. Algebra. Okay, Newton was a great guy, and he was on the West. And Einstein was a great guy. He's a nice guy. But hey, what about all of the kind of Chinese, Indian, African, Asian people that invented, for instance, algebra? Not a Western invention.
That's right. It was it's an Arabic invention for sure.
Yeah. But the decimals, West is best we're super good at taking credit for shit and appropriating shit. Like, we're the best.
Yeah, I think you also have to look at how different cultures kind of have their own. Oh yeah. We every culture has their sort of golden age.
Yeah.
And
True.
And so it's Western culture. If Western culture is like influencing more, it's because we're in the golden age of the Western culture right now. And we do have a bias when we look back, but then like in a 1,000 years, when we look back, we'll be like, oh yeah, that was like it was a really flourishing period of that Western hemisphere, and then it just kind of went back down to average. Just like we could look back and say like, oh, look at this Arabic period where they like invented all this cool architecture and math and science, poetry. They were just doing all sorts of cool stuff, and then they just kind of came back down to average. And you can say the same about the Chinese. You can say like all these different cultures have their flourishings, and then they regress to the mean.
I think we could say something about empire in there as a reason for a golden age.
I mean, the Arabs had their empire too, so like
that's what I mean.
Something to it.
Chinese empire.
Yeah.
I mean, let me add something again. I mean, towards immigration, because there seems to be a problem at the moment with immigration in certain countries, in most countries, most Western countries at least.
You mean problem with people dealing with the fact that there is immigration, or
shitting on immigrants, basically.
Yes, exactly.
And both you and I are immigrants, Josh. You're an immigrant to Sweden. I'm an immigrant to Belgium. And yet, because we're white men, we're probably one of the good ones. Or two of the good ones. Okay, do my maths.
Well, one. I mean, I don't know about you.
Yeah. Okay. Fair. But I was going to say that if you look at America, all the kind of stuff that happened, like pre the Second World War, even the fact that like they put this whole thing together for the Manhattan Project. It wasn't made of Americans there was some there, obviously, but there was a lot of immigrants working on that project.
Mm-hmm.
All the high-tech stuff that have been that has built Silicon Valley, a lot of it's being funded by Americans, but it's coming from immigrants. And what I'm saying is that when you've got a rich civilization or a rich core, let's say empire, what do they call it? The imperial core, with this imperial core, and that's the immigrants, the imperial. When you've got an imperial core, any imperial core, you tend to attract the sort of best and brightest from the other parts of the world, and then like you say, you take credit for their work because it happened here,
Right.
But in fact, so that that's where the bullshit is. But the history is definitely that kind of like abstraction and like the development of the civilization that we call it at the moment has been multi-centered. That's for sure.
Yeah.
And I like that about your talk a lot. That you gave truth to that.
If I have a regret, it's that it was very hard, especially going further back in time, to find examples of women doing it.
Mm-hmm.
They just have not been represented well in history. History has kind of erased a lot of the contributions of women, and it's just hard to find. It's hard.
I think erased is exactly the right word, right? Because I mean, obviously, women were doing science and shit. I mean, as we know, a lot of women were writing under pen names that sounded male. Right. So I think that was one really interesting thing about I don't know if you saw the Shoulders of Giants talk about the foundations of Lisp, which also I thought was interesting because it was about people and not really technology at all. There was one Hungarian mathematician who is a woman, Rosa Peter, I think her name was. And she was like the only mathematician mentioned in that talk that I had never heard of. And I'm a person who actually enjoys reading about that sort of thing. I'm not a mathematician, so I'm just an ignoramus, but I'm an ignoramus who enjoys reading about mathematics. And, it's like, surprise, surprise, the one mathematician who made important contributions in this chain that led up to, the discovery of Lisp or whatever happens to be a woman. And so, I think erased is the right word.
Yeah.
Yeah, I think we've got Ada Lovelace as well as the first programmer, and Marie Curie in the kind of like the search for DNA and stuff like this. There's
DNA?
all these.
Marie Curie.
I believe so. I believe
was it DNA? It was
radiation, right?
Oh, radiation. God damn it! Yes.
The thing that destroys DNA, Ray.
There was a woman involved in the DNA race
that Watson and Crick stole.
They stole the
results from.
And
classic.
Yeah,
she just didn't give a fuck because she just thought, well, in the end, it's all going to get found out, so I'll share.
Yeah,
but they got the prize.
Right. I heard.
So there's
I heard different. I heard like the story was that, because she was a woman, she had to be super careful with her results or they would be discredited. So she was super conservative. Right. She was getting more evidence. And then two men came in and were like, oh, we could publish this. And they just published, they did a little bit of work and they made a model of it and like published it.
Yeah.
And,
It's like how, men will apply for a job where they have 2 out of 10 must-haves and women have 9 out of 10 and they're like, I'm not qualified for this.
Right.
Yeah.
I'm laughing, but I guess it's not funny as much as it is sad. Yeah. But, what are you going to do?
Yeah. Well, let's be aware of it at least and push that awareness, which is the most important thing that we can do now, I think, But I mean, I think the whole abstraction thing, Eric, I mean, let's go back to that because the thing that I found like kind of like interesting at the end was you were talking about like a bank can be represented by a computer. And I also thought that a computer can represent a bank can get, there's like, again, there's like, having worked in banking systems, I think Josh has as well, and maybe you have as well, Eric. But, there are like a million banks on top. Like fintech is all about essentially rewriting banks in software. and bits of the bank, and so I'm wondering where we're going to go with the kind of abstraction stuff. Where do you feel like? It feels to me like software and computing is where abstraction meets the real world these days. That's where we're kind of like integrating abstractions, like on the phone and on the websites and all these kind of things,
Right. So one of the big question of my talk that I was trying to speak to answer partially was, how is it that we can basically build a bank out of electrons? Like a bank in if you really think about it, it's like accounts of gold, like big vaults of gold. Like it's just saving money, right? Now our money is all, data. But how is it that we are doing this? We like think of it as the same and like kind of works out right, so that we can just run it all on a computer. And so I try to explain that throughout the talk, that we're able to do it because there's a correspondence between the abstract operations that we're doing and the concrete operations that you would do in a bank, like moving gold from one account to another as a transaction. And that transaction is just represented as some data. And somehow they correspond. And we found these correspondences between real world operations and these abstract operations.
Yeah, well, I mean, a ledger itself is an abstraction of vaults of gold, right?
That's right. So it was pre-abstracted. That's another advantage that accounting had, is like someone had already figured out this is an information system. All we have to do is write down like what account is it coming from and what account is it going to, and we put it in each of the books. Each account has a book. And you just write like deposit from this account, this $600. And then in the other one, you say debit
and credit.
600. Instead of deposit, it's like a credit. Yeah. Credit $600 here. The other one is debit $600. And then it should all add up in the end, just like if you had golds and none goes missing, in somebody's pocket, like it works out. And so it's pre-abstracted. So all we had to do is kind of digitize that, like make a database instead of a book, right? The real hard thing that we do as programmers is we're abstracting stuff that hasn't been abstracted before.
Right.
People might be good at doing it. An employee knows how to fill out this form, and then where does it go? We'll have to fill it out. And like, we have to go through and figure out like, what are the forms that get filled out and where does each bit of information in the form go? And like, what are the values that are allowed in this form and stuff like that, and abstract it into something that we can build on a computer. And I guess another thing that I wanted to get through in the talk, and I don't think I succeeded too much at this, is I wanted to have like a set of modern thought tools that were like, this is what makes an abstraction better, and then a better, and then better. It's like we've got all these, like, it's not just like, okay, the basic, table stakes is that it works, right? It does the right thing, that money adds up correctly in the end, right? But then, like, what if you make a simplifying assumption? Like, just like in physics, you might say, we're ignoring air resistance in this problem. I've been in situations where I'm telling my boss, well, we're just going to ignore that. And they're like, oh no, but it's important. And it's like, it's a simplifying assumption. Like, I don't know if we can even come up with an abstraction that includes the complexity of these little details,
Right.
And it's web scale. Does it matter if you like miss a percentage here or there, and I try, that's really hard to do. It's the same kind of trouble that I've had with people where I'm talking in probabilities, and honestly, to someone who's not trained in probabilities, if I say 90%, 90% is 90% accurate. They think it's perfect. No, they think it's perfect. They're like, oh, 90%, that means every time, right? Like, no, it means 90% of the time, 10% is bad. There's that kind of.
But we're not good at abstractions here. I mean, the pandemic proved this as well.
That's right.
God, yeah.
That's right. Well, that's a thing that Alan Kay talks about, is like, he had this back in like the early 90s with AIDS. He was trying to show that it looks like there's not much AIDS in your community, but you're just looking at the present, very small, hole into the time, right? But if you could project it out, and that it's exponential, that people have the virus now that are not showing symptoms,
right?
And they're going to be giving it to other people, and they're going to be giving it to other people. If you could see 5 years out in the future, let's say, you would stop now. You'd be like, oh, let's stop whatever we're doing. We gotta stop this spread. But you're just saying, oh, it's just like a couple percent, like it's probably not a big deal. But that's going to double every 2 years, and then it's going to be almost everybody if you don't do something.
Yeah. So, and even if it's just a couple percent, I mean, like, I blew somebody's mind last week at work where they were like pointing to their 99.8% availability and like, that's good. And I'm like, yeah, but that's terrible, because if your system is unavailable, planes can't take off. Right. And guess how many hours a month, 0.2% is. And they were like, oh, shit.
Right.
I was like, yes.
I mean, I remember I think this was a machine learning class back in grad school.
It's called AI now, Eric, please.
Let's come to that in a minute, okay?
We'll use this to seg.
Let's have the quaint reminiscence first.
Yes. Okay. So, I mean, this was before deep learning and stuff, but it was a lot of it was probability back then, right? Like, you were doing a lot of probability. So a lot of what we did was learn probability, and how there's stuff like you're doing. We learned stuff like, if you're having a medical test and it's 99.99% accurate.
Yeah.
Which sounds great. It sounds like let's do it. Like, we'll get a lot of good information from this. The problem is that if the disease that it tests for occurs 1 in a million people,
right,
then you're going to have more false positives than you're actually going to capture people who have it. Yeah. And so this is a thing that, like, even doctors, highly educated doctors, make this mistake a lot, because if you don't, in your head, 99.99 sounds like I'm never going to see a false positive, right? But if you have 1 million people and only one of them has it, you're going to have like 100 people are going to say, or more, probably 1,000 people. I don't know. I haven't done the math in a long time, but like 1,000 people are going to have positive. And so now you have to figure out which one of those 1,000 has it. So it's that kind of reasoning that we need to get to as programmers, that's kind of where I was trying to get to, that there's like a history of like big inventions of like leaps, that this lets us think better about our abstractions. And we can apply them. And because we have computers, it helps us build the models better, because we we're not just like writing it on paper. We can actually run it. We can actually test it.
Yeah.
So, yeah.
We can get feedback quicker.
Yes,
runnable
quicker feedback.
Specifications.
That's my runnable specifications book. Yeah.
Yeah.
Is that I mean, the main idea behind runnable specifications is kind of the same thing that like people talk about declarative programming, where a lot of programming is you like work something out on paper and then you figure out how to translate it into for loops and if statements so that it gets the right answer. But what if you could just write it directly in whatever the best language for that specification is, and then it runs like ideally it runs fast enough, efficiently enough that you don't need to optimize it. But even if it just runs like 10x slower than what you would like it to, it's running. You can test it. It's maybe your model is wrong. Maybe it has problems that you hadn't foreseen on paper. And so the idea is like, we want to get to this point where we're expressing stuff at the level of the problem, and then it's good enough the way it is. And if it's not, at least you can use that specification that you wrote. It's 10x too slow, but you can use it as an oracle to write tests for the optimized system. So you can just give the same input to both and see if they get the same answer. That's the idea behind that. Yeah.
No, it's a great idea. I mean, I think the main thing for me is that it's very easy on a bit of paper or something like this to just forget how these data kind of structures relate to each other. How can you access one thing from another thing? And I've been following your progress on the book, so this idea of like, oh, you want to like get access to the price about a coffee, or you want to work out, oh, how many, what's the size of the cup, or what's this, where do these things belong? Where do these things sit nicely in the system? And I think that is a skill which I think you've talked about, which is drastically and dramatically underplayed. This ability to make those abstractions and to segregate,
make the decisions
into, and then if you can do it through runnable abstractions, then I think what you're saying is you can use it as a little laboratory to try these things out, and then again get fast feedback and say, oh, actually, you know what, because whenever you've got a low price thing, whenever things are low cost, then you will do more experiments.
Right. It's qualitatively different. Yeah. I mean, I think that is, going back to the REPL discussion, like the basically the last thing that Clojure has a big advantage on is it's dynamic. You can run it even when it's not all the way working. Like the feedback you're getting, and the number of experiments you can do is so high. Like, look, I'm not, I know we just talked about like not ragging on other languages, but I'm going to say a thing about Haskell, not ragging on it. But when I programmed in Haskell, people would say stuff like, well, as soon as it compiles and it type checks, then it's very likely to be correct.
Yeah.
And I found that to be true. I did. It was a kept promise. Let's call it that. The problem was I also often learned that it wasn't what I wanted to do. It did what I said and I got it working. And then I'm like, no, that's not really right. And so I just spent 2 hours getting it to compile to find out that it wasn't right. Same with refactoring, like I'll add a parameter to a function and then spend an hour following the error messages. Oh, you have to add this to here. This needs a parameter. Okay, trace it through. And then like, no, that doesn't look right. And undo it, right? And so it's, I guess what I want to say is the dynamic nature. We give up having a type system. Having a type system is nice. If everything's right, you want it to like keep it right. Don't let me break it, right? That's a very nice property. But the idea is that you're often not right. You're often wrong, and you don't know it yet, and you would like to see, am I right or wrong? And committing to types is expensive because it removes that experimentability.
I think that's why Clojure was, and probably still is, a good startup language, in the sense that people want to experiment a lot in their ideas and refactor things and change ideas and change your mind. And
that was
it's
Paul
really
Graham's
good.
whole thing. I'm just gonna. I hate Paul Graham and he's awful, but I will say that, you know, in his whole Lisp is the secret weapon. You know, they were a startup and they could just experiment 20,000 times faster. But back to you, Ray. Sorry.
You know, that's the point. And, you know, I think that the thing about Clojure is that you can experiment, and often you don't even need to rewrite it because it's good enough to actually deploy in production once you've finished your experimentation. But like you say, Eric, if you do need like that extra performance or whatever, then you've got a great kind of data model. You've got a great kind of set of abstractions that if you want to, you know, optimize them in like Go or Rust or Java or whatever, or Haskell, then you've kind of got the basic data model and the basic set of abstractions there ready to sort of like drop in. And you've kind of went through that experimentation phase. Now, whether anyone wants to, whether many people do that or not is like up for debate. But this feedback loop is really important. I think that's the main thing that runnable abstractions is all about.
And I just want to also say I'm not great at Haskell. There might be like workflow practices that I would have learned if I had a few more years in the language of like one thing I remember
the
learning,
type holes, I think.
No, one thing the thing I remember learning like just after I stopped was that you never modify a function if you're refactoring. You make a copy and you put a 2 on the end, and then then it lets you modify it without breaking anything that's already working. You know, and like, okay, I didn't know that, and so I didn't have that in my workflow.
Yeah. Well, there was one thing. Shit. Ray is distracting me in the chat with all of these interesting things, but you said something super interesting.
You're breaking the fourth wall here, mate. You know.
Yeah, one of you. Yeah, sorry to reveal the
behind the
man behind the curtain there. Yeah. But no, it'll come back or it won't. Go proceed.
Something about I always say interesting stuff. Thank you very much.
Oh no, yeah, the experimentation. Right. So there was another this was one of the last Euro closures back when Cognitect used to do them. And I forget which one it was, where it was, but Nada Amin gave the closing keynote. And at a Clojure conference, she gave a keynote on towers of interpreters in Scala. And somebody asked her afterwards, like, you know, what's the deal with Scala? You know, this is a Clojure conference. And she was like, yeah, I rate Clojure too. And one interesting thing she said is that I use Scala when I'm solving a problem I already know how to solve because the type system is helpful. I use Clojure when I have no idea what I'm doing and I'm exploring the space. And like that really resonated with me. And I realized in my work, I'm almost always in the latter. Like very rarely am I solving a problem that I've already solved a million times, right?
Yeah, that's such a great place. Right, I think we're on our clock. It's like so many hours now. We've really kept you for a long time, Eric. You know,
deep.
We're very grateful for it. But I think we should start to wrap up because it's like,
yeah.
I need to go to bed over here. You know.
Yeah. I should go too. I was going to say something. So, how do we wrap up? Y'all are the hosts.
God damn it! Yes. Okay.
Did we lose Josh?
Oh yeah, I think he's just frozen a little bit there. Maybe she's back. I don't know. What I was going to say was maybe it's to wrap up a little bit was you're writing books in general. You're adding a lot to the sort of closure community in terms of your educational material, etc. What's your sort of forward-looking advice to maybe some decision makers out there, maybe who are wanting to adopt closure, or maybe who are kind of, let's say, at the core team or core team appropriate? Maybe it's two kind of like camps there. Like maybe you can't talk to the core team. Forget those people. I mean, they're very difficult to reach, I think. But let's talk to the community or to adopters of closure. What's the kind of prognostication from Eric Normand today?
The prognostication.
Your forward-looking forecast, and this is not a financial advice, but
no, don't put any stock in that. But
no pun intended. Clearly.
Well, I think closure is not going anywhere. Like, it has cemented itself in enough big companies that it's going to be around. So it's not like fading out of existence, anything like that. I think that it actually is going to have, because of the support from Nubank, it is going to have new, what do I want to call it? New development, like this whole ad libs thing, I think is great. It's a big deal. I don't know if we'll ever see the kind of growth or excitement or even just like media presence that we saw at the beginning of closure. I don't know. It doesn't look like it's just going to happen. It's not happening now. And so, I've talked to a lot of people outside the closure community, and they're like, I haven't heard about closure in so long. Like, I thought it was dead. I thought no one was using it. Which is just the way people think, they don't hear about it on Twitter. It's not in their circles, and it's not like big enough to like burst their internet bubble. You know what I'm saying? It's like not on the front page of Hacker News that much anymore. It's that kind of thing that we're not that present for them. But at the same time, like, you don't know how many people I met at Heart of Closure who worked at Nubank as like junior programmers, learned closure, and then moved on. And they're like at startups, they're doing closure at other companies. And this is just the people in Europe. Like, I just imagine in Brazil how many more people are still there who like are moving on from Nubank but still want to do closure. So I think that there's something there. There's something brewing. Like, Nubank, for all the criticism that may or may not end up in the podcast of Nubank as a steward of closure, I feel like they are educating a lot of people in closure who might not even have wanted to do closure in the first place. They just wanted a job, and now they're learning closure and they're getting good enough and they're moving on and looking for bigger opportunities. That's great. That's awesome. That they're this engine that's like that. Frankly, it's the kind of thing that I've always wanted for closure, is like a place that was going to train you up and give you a decent salary and like, do it at scale, and then have this just people coming out of them there that are good enough. And I think that that's happening.
Pitch did that as well, and I think to a lesser extent maybe Griffin over in London, because I know they're hiring programmers who don't yet know closure. So I think exactly, Eric, and that was what I was getting at with my old like comment way back when on I don't think Nubank cares about maybe the
Let's not relitigate those lovely points, though.
No. But this is the positive side of it, which is exactly that Nubank will hire programmers who do not yet know Clojure.
Yeah.
Right. And then teach them Clojure, or give them. I mean, and I've heard really, really good things from folks who've worked at Nubank about the support and education you get. So, I mean, it's very structured education. It's not just like, here's a code base.
They have a team
Clojure,
that's
please.
that's like dedicated to education training, and yeah.
So I think that in a sense, I hope that Nubank is not the only producer of new Clojure programmers.
No, but they're probably the biggest, and they could dominate in terms of numbers. And but that's frankly, you want something at that size, right? You just need the scale. And I think that's great. Like it could keep Clojure fresh, like new people coming in, and that's really what we need. Like, we all have gray hair. True. Like, you don't want it just to be a gray hair language. You want it to have some fresh blood.
Right. I think that fresh blood is a perfect way to wrap it up. Thank you again very much, Eric, for your words of wisdom.
Thank you for having me.
We'll have you back again when Josh has agreed on a new way to do this broadcasting.
I thought you were going to say when Josh has been fired and we have a new host who wants to re-interview all the guests.
I wasn't going to tell you that live on air, though, was I?
All right.
We're going to rate and review your performance afterwards, Josh. Eric, be prepared.
Okay. 5 stars. 5 stars.
Okay, perfect.
Thank you. Yeah.
I give him 5 stars.
Yeah, but it was great, Eric. Thanks. This is the longest I've ever gotten to talk to you. So hopefully this will be not the longest we'll ever talk in our lives, but it's been fun today.
Yes, likewise. Thank you so much. This was great.
Okay, bye.
Thank you for listening to this episode of DefN. And the awesome vegetarian music or the track is Melon Hamburger by Pizzeri. And the show's audio is mixed by Wouter Dullert. I'm pretty sure I butchered his name. Maybe you should insert your own name here, Dullert.
Wutzer.
If you'd like to support us, please do check out our Patreon page, and you can show your appreciation to all the hard work or the lack of hard work that we're doing. And you can also catch up with either Ray with me for some unexplainable reason. You want to interact with us, then do check us out on Slack, Clojurian Slack or Clojureverse, or on Zulip, or just at us at DefN Podcast on Twitter. Enjoy your day and see you in the next episode.